Hello. Today we're focusing on a couple ways we can apply Inter-VLAN routing. And without further ado, let's get started. So in order for hosts in separate VLANs and separate subnets uh, to have communication, they need a layer 3 method for reachability from the layer 2. One method being layer 2 to layer 3 routing on a stick, and then the other method being layer 2/layer 3 switch virtual interface communication. And you'll see once we get started. So the instruction has here, we need one router, one switch here, one router, and a couple of PCs because they're going to eventually ping between one another for routing on a stick. And then the switch virtual interface, we just need one multi-layer switch, and we're going to need a couple of hosts to ping between one another. So for the routing on a stick, let's go ahead and grab our router. And then let's go ahead and grab a switch and two hosts. Let's choose 13. So first thing is the switch is going to need to carry the VLANs between these two different hosts, which will be on two different subnets. So let's go ahead and before we get this far and configure our switch, just so we can see what we're talking about. Right now, the host, they don't have any IP addressing. So basically, I'm going to give them separate subnets and just try to ping between them without the routing on a stick configuration. And we're going to see that that ping is going to fail. Let's get a better visual to see. When I look up the network interface card configuration for PC1, we see it has an IP address of the 10.0.0.5, 255.255.0, and PC1 across from the switch, well, on a separate port on the switch has a 172.16.0.5, 255.255.255 class B addressing. So when I go to ping this address, it's not going to work because they need a way to communicate. These host devices need a way to communicate between one another. And that's where routing on a stick comes in. The switch here that hosts both machines are going to run the ARP process between one another. And then this port is going to be trunked across from the router, and the router is going to have layer 3 subinterface 8021Q encapsulation ran on the interface in order for this PC that's in a class 10, or excuse me, a class A 10.0 IP address format versus this one here, PC1, which is in a class B. So let's go ahead and just to demonstrate, PC0 is 10.0.0.5. We go over here to PC1, and if we made it a part of the 10.0.0.0/24 network, let's just give it a 4. We can see that without configuring anything on the switch that they do already have reachability, because one switch equals one broadcast domain. So let's go ahead and ping 10.0.0.4 without any actual VLAN configuration, and we get immediate communication. So let's go back and configure PC1 the way we want it in a separate subnet. So we can then go ahead and configure our routing on the stick to have our router do our routing for us between VLANs. So the first thing we're going to do, per the instructions, it says the switch needs to carry the VLANs. So let's go ahead and configure our switch to carry the VLANs. And then the next thing it says for us to do is go ahead and put our hosts in the right VLAN. So let's run the do show interface status command, and we're gonna see that we do have one host at F02. I think that's PC1, and we do have another one connected here at port 13. I think that's PC. Actually, this is PC1 and the other one's PC0. So let's start off with PC0. That was on F02, and we're going to make it a part of the VLAN 10. And the switch port non-negotiate just makes it bypass the STP process, spanning tree process. And these spanning tree processes I'm going to run here are for access ports. The port fast just enables it to bypass spanning tree and immediately go into forwarding. So that's the only one we're going to run. I guess we could run BPDU guard as well for it to not accept any BPDUs. And then we're going to do the same thing for interface. I think that was 13, except for it's going to go into VLAN 20. Okay, and the next thing we need to do after we put the host in the VLAN and create our VLANs is to do trunking on the port across from the router, and that's going to be our port number 1. And you're going to notice it won't come up until the router interfaces have their encapsulations and their IP addresses for the VLAN reachability as well. So let's go ahead and configure our trunk on the switch. Okay, great. So, and even when we run the do show trunk, you won't see any information populate just because the router's interface isn't okay. So now that we have the do show trunk, we can actually see the interfaces that are allowed on the trunk here. So now the next thing we need to do is configure our router. Make sure you save your work. And the router here, you won't see this interface actually come up again until the router's configured. And the first thing it says we need to do is configure our sub interfaces are created and encapsulated with the .1Q. So we need a sub interface for both VLANs to pass, and we'll choose just one in order for that to happen, which is the interface directly across from the switch. And I think we chose G00. So let's take a second look, or we can pick it. Yep. So now we have to select our G00. Actually, we need to go into sub interface mode with G00 to create our first encapsulation for VLAN 10. Then we give it this is essentially giving it a gateway in order for the VLANs to pass between the switch to the router, back to the switch to the other hosts. And we'll give it an IP address of 10.0.0.1, 255.255.255.0. The same IP address, or actually we can't do that. It's telling us here we need first to create the encapsulation .1Q for the router to recognize that we're doing the sub interface Inter-VLAN routing. And we're going to do this one for 10. Now we can give it an IP address of the default gateway. And we're going to do the same thing for VLAN 30. And give it its IP address as well. And then I'm just going to go to the main interface and do a no shutdown for good measure. And then we're going to run do show interface brief just to double check that we have the right encapsulation.1 queues under the router interfaces. And we do one for VLAN 10 and one for VLAN 30. So next thing it says here, which we've already done, we did the IP assignment to the sub interfaces. We ensured the port on the router came up with the up status. And the next thing we needed to do was have the host in the proper IP assignment and ping between the hosts. So now that we have everything configured, let's go ahead and ping between 0 and PC1. And as we know, PC1 should have that 172.16.5. It's normal for the first ICMP message to fail, but that's just because it's completing the ARP process. And we would be able to see that in if we ran like the simulation mode here. Let's double check everything is correct. So we got PC1 172.16.0.5 with the right default gateway. And then we have PC0 here. I'm sorry, PC0. And it has the configuration for the 10.0.0.1. with the 10.0.0.5. Okay, let's ensure the right ports. So this one is line change state to up. Okay, let's make sure this switch port is actually up on the switch. And it says it is, so let's retry. Let's just retry the ping before we make any real configurations here. That's correct. What about our router? G00. The switch is trunking. Let's see. Okay. So that's our misconfiguration here. This port is a FA013 is supposed to be our access port, not configured for trunking. So right now there isn't anything passing across from PC0 to PC1 because we have this port here on the switch configured to PC1 configured as our trunk when it's really supposed to be port 1 here. So let's go back to our switch and swap the settings. now this should be our port 1, which is across from our router. Let's give it a little bit of time to recalibrate. And let's retry the ping again. This time with the correct port across from the switch carrying the VLANs. It still needs to run through its ARP process, so it's normal for the first ping to at least fail. And there we are. So we have successful reachability between layer 2 and layer 3. I'll just draw a line for it. To give it the context. Right now, you can think of this as actually two completely separate layers. One doing data link layer work between using MAC addresses, source and destination ports, and one being layer 3 at the top, which is mainly the router function here, performing the encapsulation.1q for the IP packets to move between the sub interface back down to layer 2 to the next host. So that is routing on a stick. The next thing we need to configure is switch virtual interface scenario here. What we need is a couple of hosts. And the great thing about this is routing on a stick is mainly used for a smaller network, but the problem is, again, this bottleneck. You only have one point of failure here. And suppose this link goes out, or this port goes out, or this port goes out, there's no reachability between these hosts as to where the switch virtual interface is here. Let's grab our multi-layer switch. With the switch virtual interfaces here, we can create redundancy through the network, and we don't have to add that extra device 1, 2, 3, 4, as opposed to 1, 2, 3. We have our layer 2 or now layer 3 enabled switch doing the routing for us here, as long as it has the right VLANs, as long as the switch virtual interfaces are created and routing is enabled. So let's go ahead and connect our host here. And then it says here on a multi-layer switch, we need to have the same VLAN. We're going to use the same subnets and VLANs as we did here for routing on a stick demonstration. We need this switch carrying the VLAN. So let's go ahead and configure those. You'll see how it's much easier. It's less network congestion. It's less bandwidth utilization. It's better for load balancing and redundancy. You have to imagine this supplied across an entire interface, an enterprise or production network versus a series of these multi-layer switches running east to west. It's more efficient. So let's go ahead and create our VLANs on a multi-layer switch. And the way to create the switch virtual interface is to run the command interface. Let's see. I think let's drop down first. Yep, it's interface VLAN, and then we type the VLAN identification, and you see it immediately pops up. And the next thing we do is we can add a IP address here to the switch virtual interface, and that's going to act as our default gateway, all within this one switch, performing layer 2 and layer 3 functionality. But take a note that we would still need an actual router if we were trying to reach the global internet. This is only good for across a LAN, so to speak, or a very large campus area network. So let's continue with our IP addressing. And we'll give it the IP address of the default gateway for our PC2 over there. And then we're going to do the very same thing for interface VLAN 30. And give it an IP address of the default gateway for the PC3. And drop down and make sure that we enable IP routing, because this again is a multi-layer switch, a layer 3 routing enabled switch, but we need to run this command in order to make it perform that way. So let's go ahead and run do show IP int brief, same like a router now, or excuse me, int status. It's the same as like a layer 2 switch. And we should see the, no, actually it is do show IP int brief. Yep, we can see them here. And then we could also see them in do show run the virtual interfaces. Should be here with the IP addresses shown. Let's go ahead and configure our switch ports for our switch ports for our access hosts. Okay, great. So now let's go ahead and configure our host, and we're going to put PC2. We're going to give that an IP address within VLAN 10, and then we're going to give PC3 an IP address within VLAN 30. Okay, great. So let's go ahead and ping from PC3, which is in a Class B subnet, on over across the multi-layer switch virtual interfaces that are sharing uh, the routing functionality on the multi-layer switch between one another. Okay, great. So what we've been able to demonstrate here was the split between layer 2, which is MAC address based from the source and destination MAC addresses, performed at layer 2, which is the data link layer, and layer 3, which is about the IP addressing data packets. And how that travels is from the host here across the wire to the switch. The switch looks at the source and the destination MAC addresses, and it takes a note of that in its Ethernet frame before it's sent over to the router. The router, I should say, decapsulates rather the Ethernet frame, and it turns it into a IP packet, and it does its routing and functionality here amongst the encapsulated subinterfaces, and then the packet is sent back to the switch where it's formed into another Ethernet frame. The address resolution protocol is ran to map the IP address to the MAC address, and then that Ethernet frame is finally sent to its destination. So that's layer 3, and